Hello, I'm Michelle Thornton and I work at the ORNL DAC, which I'll tell you a little bit more about in the next slide. I want to thank you for allowing me to present to the agricultural industry at Commodity Classic 2022. Today, I'm going to present on a data set called Daymet, whose production and distribution I lead, and look at how this data is being used in agricultural applications. First, a little background on where I work and how that fits in with the NASA community. As I mentioned, I work at the ORNL DAC. The red box on this map shows where the ORNL DAC is located. A DAC is a NASA Distributed Active Archive Center, and the ORNL DAC is located within the Department of Energy's Oak Ridge National Laboratory in Oak Ridge, Tennessee. As you can see from the figure on the left, there are many DACs located throughout the United States. So what does a DAC do? DACs curate, archive, and distribute data from NASA's Earth-observing missions. This can include satellite data, data collected from instruments on aircraft, field measurements, and modeled data. Importantly, DACs strive to ensure that NASA's data is available and accessible to users, believing in open data access for open science. One of the many datasets that the ORNL DAC distributes is called Daymet. Daymmet is a highly downloaded dataset and has many applications in the natural sciences and natural resources. The Daymmet dataset provides long-term, gridded data of daily weather and climate variables by interpolating ground-based observations through statistical modeling. If you'd like to know more, visit the Daymmet website listed here. Shown on the left are a few annual climatologies derived from the daily data. Shown are average annual maximum and minimum temperature, the annual total of daily precipitation, and the annual average of daily vapor pressure. In all, there are 7 Daymmet variables, including shortwave radiation, snow water equivalent, and day length, in addition to the 4 I just mentioned. Daymmet data have a daily temporal resolution. The spatial or pixel resolution is 1 kilometer by 1 kilometer. The available time range is 1980 to 2022, and the primary distribution format is in NetCDF. Having access to daily, long-term weather data allows for a comprehensive derivation of many bioclimatic variables. I've listed a few here. Using daily maximum and minimum temperature allows calculation of growing degree days, which provides insights into growing season's start, end, and length. It's possible to look at annual precipitation seasonality and variation. Analyzing decadal normals and derivations from normals is possible. In the images starting in the upper left, I show some examples of what type of analysis that we have available as tutorials. The first is an analysis of climate impacts on wine production in California. That demonstration was done as a collaboration with Esri. The figures at the bottom show images from a tutorial that produced monthly climate normal and compares the departure in June of 2021. You may remember that was a particularly hot period in the Northwest. And the line graph shows those annual averages that correspond to the location of Portland, Oregon. Now, I'm not an agricultural scientist, but I do follow the literature that cites the use of the Daymmet dataset, so I'm aware of its use in agricultural applications. For the next few slides, I'll share some of those examples. This is a paper published in Frontiers in Sustainable Food Systems from a study done at Iowa State University in the Department of Agronomy. We see in the abstract that a process-based cropping system model uses a few recognizable input data sets, including Daymmet. From this same paper, looking a little deeper into the methods section, we see that a number of daily Daymmet variables are used as inputs to the APSIM model framework. It's also noted that the data are obtained from the Daymet Weather Data Service based on the geospatial coordinates of the field centroid data. In a few slides, I'll share what that Weather Data Service likely is. In this study, the first author is from the University of Kentucky and the College of Agriculture, with co-authors from a wide range of institutions, including NASA, the Jet Propulsion Laboratory, and Agriculture and Agri-Food Canada. This study had a very large spatial extent across North America, and in the description, we see that crop phenology is correlated to temperature using Daymmet to derive average, minimum, and maximum temperatures during the crop planting seasons, April through June, and harvesting season, August through October. To demonstrate the large North American spatial extent of this study, here's an image from that paper showing estimated planting and harvesting dates. And the last of many agricultural applications that I'll share. This one is a little different in that it's an example of a tutorial and open source code that demonstrates how to access data through one of Daymet's APIs. This is from a lab in the Department of Agronomy at Kansas State University and helps users retrieve and process agri-meteorological data using R from a few different sources. Now let's turn our attention back to the ORNL DAC and look at how we structure Daymet data and provide data services that allow access to this data that doesn't depend on downloading terabytes of data for all of North America. As a starting point, the ORNL DAC has a specific Daymet project page at daymet.ornl.gov. Here, you'll find a lot of information on Daymmet and access to the Daymmet collection of data. As I've mentioned, the main data are the daily weather data, and we also have annual and monthly climatologies. The daily data is provided in a netcdf file format, which can be thought of as a three-dimensional cube of data, with space in X and Y, and time as the third dimension. Typically, a researcher wants a subset of those data. There may be a need for data at a specific location over time and for many variables. I'm representing that type of data need as this long line. Or a smaller gridded subset of the data may be needed. I'm showing that with the smaller cube. I'll next demonstrate the tools that we have that allow for these different access patterns. From the Daymmet homepage, there is a Get Data link that shows the download and data access methods that are available. I'll show the single pixel extraction tool and one of the web service options that allows for gridded subsetting. In addition, users have direct download access to all of the data, as well as the climatologies being available through a tool called SDAT. The Daymmet single pixel extraction tool is first presented as this GUI, which allows you to enter a latitude-longitude pair, select which variable or variables you'd like, and then provides a preview of the data as well as a graphical visualization. From here, you can download a simple CSV file of daily data from the location you queried. We also see on this page that there's an automate option. Scripts and information for setting up and running those scripts are available that will allow you to automate multiple locations simply by providing a text file of latitude and longitude pairs. These scripts leverage the Single Pixel Tool web service API. The journal article we saw earlier was leveraging this API using the R software. Here, in the map on the left, is an example of a week's worth of downloads from the single pixel tool. I sometimes map the point locations that our web service logs. This one in particular looked like it was broadly over agricultural land across the Midwest. For this particular week, there were over 17,000 locations queried. The image on the right shows an area zoomed way in which each of the small yellow dots are a point location that was queried that week. We can see that most of that is over agricultural land. In my final example of data access, we have guidance on how to access another web service, the NetCDF subset service, which allows you to enter a latitude-longitude bounding box that will subset a smaller gridded area for variables of interest from the North American data set. This too can be automated. Now the output of this access method is a multidimensional NetCDF file. And in conclusion, we've seen that Daymmet is a highly downloaded dataset with many applications, including in the agricultural sciences. We've seen that journal articles support that the daily Daymmet data are used extensively to create bioclimatic variables in phenological and other crop level applications. And the ORNL DAC provides standardized data and web-based access methods to encourage open data and open science. Thanks for the opportunity to present at Commodity Classic. Hope you have a great day.